talk today that I'm going to present to you is how to use a data-driven approach for safety mapping in Lisbon, and as well how to do route planning, avoiding some of the dangerous points that we identified in the same city. So the starting point of this project was we were two co-founders 3 years ago, one of us with a bicycle accident, second of us with a master's project in at my university in London. We heard about each other, and we start this project that is mostly driven by social impact as well, obviously data-driven, but at the core of it is a very personal issue. We know that having more people cycling has a lot of benefits. On one side, it contributes for the decrease of greenhouse gases emissions, but at the same time, it promotes more active lifestyles. So it has a clear environmental aspect and a clear health aspect. And this became even more clear during the pandemic, COVID-19, that started 4 years ago. So one of the major issues of having more people cycling is obviously the number of fatalities that are still occurring, not only in the European Union, obviously, with around 2,000 deaths per year, but a bit around the globe. And even bigger than those numbers, than the deaths, are the number of injured people. Majority of these accidents, they are just not tracked at all, especially the light injured, and some even of the most severe, they are just not tracked. And at the end of the day, this might underestimate actually the threat that it can be still cycling in some cities. It's improving. In Portugal, no doubts, with increase of cycle lanes. It's improving in any other cities, like London, for example, where the drivers are more aware over time, but there is still plenty to do. And if we see, there is still a majority of the population still considers to be unsafe to cycling. And here there are completely two different aspects. There is what is actual safety and what is the perception of safety. And the correlation between these two sometimes is not straightforward. And what we tackle in Cycle AI is, at the same time that we identify the dangerous points, we try to understand what is people's perception of safety. We built an AI model that is able to calculate the safety without having to ask people every single time whether they have passed by a dangerous point or not. And so the core of our approach were two crowdsource models, and it was using these two crowdsource models that we built an AI model that is able to predict where the dangerous points are. So we firstly used this hotspot map, where we ask people places they have passed by they consider of risk. And just to point, in a map we got several votes from, at this point, almost 500, where multiple dangerous points were identified, not only in Lisbon, Porto, and many other places around. And we have as well the second crowdsource, again, that allows us to build this model that is able to predict people's perception of safety. So, and at this point, what we ask people, in the previous crowdsource, we ask where are the dangerous points that we passed by. Somehow an approach similar to Waze, but in this case done a posteriori. And in this second crowdsource model, we ask users between two images, which one looks safer. And by getting all these votes together, more than 100,000 votes from over 5,000 people across 73 different countries, and these numbers are important because it is ensuring us that we got the most impartial perception of safety of people. Because if most people that would be voting in this crowdsource were Portuguese or Spanish or English, then it could be biased. And that's actually one of the downsides of our approach, is when we are getting this data in an unbiased way. It's important to guarantee that we do it, not only making sure that we ask people perception of safety, not only in a wide range of countries, but as well like a wide range of ages, wide range of gender, and so on, so on, so on. So it's important to guarantee this so that we can have an impartial model that is able to estimate where safety is. And then, by having these votes with us, what we did is that between two images, we asked which one looks safer. We rank all the 20,000 images that were in that crowdsource. So we're going to end up with images that were considered safer by the crowd, and some others that were considered unsafe. And what we went to doing after was, for the safest images, what do they have in common? Which objects do they have in common? Cars, traffic lights, people. Not only objects, but as well structures. Which structures do they have in common? The safest ones and the unsafest ones. And like, for example, in this case, we segmented the images to identify over 80 different classes. In the object detection before, we can identify a similar range of classes. So before, we are using, for those of you who are familiar, we are using YOLO v5, which is a very famous object detection software, mostly for its real-time capabilities. But as well, when we are working with like hundreds of thousands of images, they are not necessarily high-resolution images because we are working here with Google Street View images. But still, when we are processing this amount of images, having a software that can rapidly process going through each one of them, it's very important. Given, of course, that our computational capabilities are not at the level of a much bigger company, like some of the ones that are here in this conference, like NVIDIA, for example. Although we are having the support of Microsoft, without them, it would be completely impossible. So we have access to their high-performance computing through Azure. Without it, it would be completely impossible. Because for you to see, for detecting where are the risk factors in these images that got ranked due to our crowdsources, the object detection, you can easily do it with a small computer. It's nothing that heavily computing. But for the image segmentation, having to look at hundreds of images, pixel by pixel, is highly demanding. And for you to have an idea, this is to build an entire map of safety for a city with the size of Lisbon. It took us around 2-3 days with a virtual machine that we're probably spending like more than $100 per each hour of processing data. And with this, so we scored these images from like the safest to the unsafest, 20,000 images. And then what we did, this ranking was done with an algorithm that is called TrueSkill. That is a very well-known algorithm for ranking players. So for example, if we play any game where it implies one player fighting against the second player, it's typically used this algorithm TrueSkill to calculate the end ranking for the whole players that were involved. So I can even tell between like two images which one has a better ranking, even if those two images never appear together in the perception pool, in the crowdsource. So it's, and that's the thing, and one thing that we realized over time is that it's much easier for a human to be able to tell between two images which one looks safer than if I ask any of you in a scale from 0 to 10, which one is the safest one. Much easier and much more accurate. And with this information, we train our AI model that doesn't receive directly an image as input, but receives the output of the object detection and the image segmentation. So it's going to receive how many objects from this class were in the image, and how many pixels of each class was in the image. This is the input layer of our neural network, around 100 different features, with many other hidden layers. And the output layer is simply a value from 0 to 10, retrieving the perception of safety that we gathered through the crowdsources, and now we don't have to ask again, because once we have our model, we just feed it with the image as input, and we immediately get the perception of safety. It's a simple sequential neural network with multiple hidden layers, and it's going to get more complex over time. Right now, we are only considering whether the object is there or not, how many pixels for this class. So one of the next steps is going to be considering not only whether the object is there or not, but relative locations in the image between the different objects. And right now we are initially, we achieved an accuracy of 75% with our neural network. And now we attained already our Bikeable 2.0 that we're going to publish an article on it very soon with Tiago, that is also here and will join for the questions and answers. We managed to achieve 80% accuracy, which means that 4 in 5 images were correctly identified as dangerous or as safe. And especially when you are part of a company, it's very important your approach to be scalable to different markets. And what ensures the scalability of our approach is Google Street View images. So for us to tell that a dangerous point is there, the only thing we need is our neural network alongside Google Street View images. And that's the interesting thing, because most of the places where there is cycle lanes available, it's a very bad sign if the roads with the cycle lanes are not the safest ones for you to cycle. But indeed, the majority of the places where in the cities, there is just no cycle lane. And between 2 roads without a cycle lane, which one is the safest one? And there are multiple approaches ongoing, but they mostly imply a person or a group of people to go to that place and rate the place based on this criteria, and this criteria. Just tell me in 1 to 5 stars, how good is the pavement? In 1 to 5 stars, how good is the lighting? And this is exactly one of the benefits of our approach is we just don't need that. We can simply, using the Google Street View, our AI model, simply mapping the cities like we did for Lisbon. And this was the sequence. We start with Crowdsources, and this crowdsourcing data was not only very important in the perspective that allowed us to build the neural network, but as well, it was one of the very big points of it was the fact that we brought just any person living in Lisbon, any person who cycles could be part of it. So we literally empower multiple millions of people that because they just don't have background in data science or because they don't have background in AI to contribute to this AI model. And you would be surprised on the availability of people to do so. Obviously, at the beginning, we couldn't give nothing in return. We are doing this out of our free time. But one thing that surprised us a lot was how much people are willing to contribute for a cause that they believe that is worth it. And when they believe that the person that is asking them to contribute, if they believe that those can actually help solving it, it left me very surprised how people are willing to help. And this is the sequence. As I was saying, we did this safety map for Lisbon. We did this safety map for Prague, Czech Republic. And we are going to do next in Coimbra. And this is a good example on how specific risk factors were identified in the images. For example, here are rail tracks. And then the final classification of a point is simply a weighted average of the presence of these risk factors. But it's very hard to tell analytically what is this weighted average, because what is behind is more like a black box, is the AI model that we built, our neural network. And this is an example. We can identify this risk factor is, for example, very associated with the unsafe images. And there is some others, like, for example, the presence of vegetation, the presence of cycle lanes, the presence of good illumination in the cities that are typically associated with safety. And So at the end of the day, what we got was a large distribution of points in the city of Lisbon, but we didn't stop there. We went a little bit further so that we could tell neighborhood per neighborhood which ones were considered the safest and the unsafest. And so in Lisbon, for example, one of the safest was considered to be Carnide. And we saw that one of the main factors that was behind it was the presence of a lot of green spaces. But on the other side, one of the unsafest ones was Alcântara, Santa Maria Maior, which very much due to one of the biggest risk factors that we identified, rail tracks on the road. And these can be done not only at neighborhood level, but can be done at the city level as well, comparing between two cities, which one is more cycling friendly. And when I say cycling friendly, it doesn't have to be limited for cycling, can also apply to other micromobility means, scooters, for example. And I think this is, as far as I know, this is the only analytical way, or at least considering a wider range of factors, to assign what a dangerous point is, to assign what the unsafest neighborhood is, and it allows to benchmark how different cities are doing, how different countries are doing. And but as the title of the talk was suggesting, we didn't stop in identifying the dangerous points. We went a little bit further, and we also made available a route planner. A route planner that is heavily based in open source software. We use the OpenRouteService for routing people, not just in Lisbon, but as well in Prague, as I was saying, while avoiding these dangerous points. So we can insert, I want to go from this point to this point, point A to point B. We give 3 options in our app, either in the safest way, either in the shortest way. There's a third option that is the balanced one. So we also provide an option that the person can pick, can decide as well, like the best balance between safety and distance. And one important factor of it as well is that not only we use OpenRouteService, but what is behind the OpenRouteService is the OpenStreetMaps. And as part of this project as well, we updated the cycling network in Lisbon with the most up-to-date data at the time, April 2023. So more than Google Maps, more than any other route planner, we are providing the best routes according to safety and distance, while we are providing the best routes while considering the most up-to-date cycling network in the city. And not only we are using this information, but because this is an open source map, all of you can use the same data that we made available publicly. So this app has multiple features centered in safety, not just identify the dangerous points, avoiding them, but as well, one thing that we are seeing over time is people are not interested simply doing their journeys using walking, using their bicycles, using public transport. More and more over time, we see that what people want is multimodality. And here in this case, we provide where the closest shared bicycles are. We tell people how to, exactly what's the shortest walking direction till there, cycling until the closest point to their final destination. So our approach is, we published a paper on our scientific approach to identify dangerous points, and we published a paper exactly with the same title as this talk on how to use our technology to identify dangerous points and then to planning routes around them. And they are published in Sustainability and Smart Cities. So we're having some traction. We start with the pilot with bird scooters. Then we did a pilot in Prague, finally a project in Lisbon. And now we are discussing with 2 other cities to expand our approach and hopefully increasing the amount of users that we currently have. We have had some recognitions lately, which makes us proud and tells us that we are going in the right direction. So this is the team that is behind. This is the last slide. I'm here with Tiago Tamagusco, which was a key part of the Lisbon project, alongside Mateus Correia, that is not here today, and with Professor Adelino, Miguel, Codrin, Dora, Luisa, Beatriz, Rodrigo. This was possible, and I'm very thankful to all of you, for the 9 of you, and for all of you to be here today. Thank you very much.
Fica aí. So thank you, Luís, for the talk. It was really great to hear about how you use open data to create this safety score. We already have a lot of questions from the audience, but only 4 minutes, so I'm going to try to keep it short. So our first question is from Daniel Reinstein about the bias of the safety perception that people have. Someone in Portugal and someone in India can have completely different perceptions of what is safe. Have you considered some way of tackling this?
So we acknowledge that even though we can make a big effort for the algorithm not to be biased, it will still be. And that was part of the reason why in the crowdsource, in the perception pool, we pick images from Lisbon, was because we believe that most likely we'll be analyzing images of Lisbon. And that was like an easy way to make sure that we'll get better accuracies from the beginning. We acknowledge that bias. But what we try to do to tackle it as much as we can is making sure that the people who contribute for our crowdsources are not only from here, but a little bit from everywhere. We put together as well some of the data where while we are getting people's votes, we are not only keeping that information, we are as well keeping where the person is located by retrieving it automatically, and obviously always in an anonymized way, and can only get the information of the country. But yeah, in terms of, we get some data as presented to you before, the countries where the people are from, that allowed us to make sure that we go in that direction of making it as unbiased as possible. Mm-hmm.
And there's a similar question related with bias, since we're already talking about this, from Ricardo Ferreira. So how does identifying dangerous spots using the Google car, so when you're not riding, biases the data versus when people are riding it? And Ricardo is asking if you have thought about implementing physical buttons, like in the Gira bikes, that users can press whenever they are feeling vulnerable, or some side app.
Yeah, can you repeat the first one, please?
How does identifying dangerous spots when you're not cycling bias the data compared to when you will be cycling? So you use the Google car driving through the streets.
Okay. So my understanding of the question is we try to make sure as much as possible that who is voting our data are cyclists, and because those are going to get best perception of what is safety for them or not. I do as well acknowledge that the perception of safety from someone of you today might not be the same as tomorrow. But what we realize is that if we put together a big range, a lot of votes, the most subjective parts of it, they tend to cancel out. So at the end of the day, if you put like a big range of votes together, only what the majority of the people tend to consider unsafe is actually what it is at the end. And for the second part of the question, we added as well to our approach a reporting engine that allows people to pinpoint dangerous points just like in Waze. And that we consider that for the route calculation as well.
Mm-hmm. Thanks. Now, a more business-oriented question by Ricardo Chaves. How expensive is it to classify a city of the size of Lisbon?
So it's for size of Lisbon, the cost of all the images, as more images we get, as cheaper they become individually. We used over 100,000, which is around 1,000 euros per city in the size of Lisbon. And this is a one-time cost. And every year, ideally in a European capital, you have to update it accordingly to the most up-to-date Google Street View images.
Okay, just a final quick question, since we have a few seconds. Sorry, this changed. How to use the safety map to cyclists, and are the maps available for the broader public?
So alongside this project with Lisbon, I don't think we have, like, one of our approaches was giving to municipalities and tell them dangerous points are here. If you are planning to build 2 cycle lanes, we advise you to build this one first because it crosses more dangerous points. This is one. I think safety maps are more useful directly to municipalities. For the end user, I'll say is the app, and yeah, and I'll say that's it. Yeah.
Mm-hmm.